Are we starting? Oh. Hello and good day, geometry. We are continuing talking about polygons with CO9. And our job today is to identify and draw regular, convex, and concave polygons. And I know that you've come across the words convex and concave in science before. And now we're going to kind of apply that concept, apply those words to polygons in mathematics. So I only want your hand up right now if you can define for me a regular polygon. If your hand is up for any other reason, put it down for now. Jack.
A regular polygon is an enclosed figure with at least 3 sides that are straight.
That is a polygon. But in order for the polygon to be regular, it's got to have some other pentagon. In order for a polygon to be regular, it has to have some other characteristics. Kylie. That's getting into the convex concave piece. Aiden? Beckman?
A convex polygon
We're
that
not
is
on.
both equilateral and irregular.
Okay. A regular polygon is a polygon. We only have 10 minutes left. That's why I'm moving us along here. With congruent sides and angles. A regular polygon is a polygon with congruent sides and angles. Okay, so an example, probably the most famous polygon you see on a daily basis, if you're paying attention, is like a stop sign. Okay, that is a regular octagon because it's an octagon. All sides are congruent, right? And all angles are congruent as well. A square would be another example of a regular polygon. All sides, all angles are congruent. Okay. Now we get to convex and concave. And Kylie, go back to what you said. What were you describing? Okay, so a convex polygon is a polygon with sides that, when extended, do not go inside the polygon. Okay, a convex polygon is a polygon with sides that, when extended, do not go inside the polygon. So this octagon would be an example of a convex polygon also, because if I extend these sides, kind of imagine just extending each of them here, none of them actually go inside the polygon itself. They all stay on the outside. Okay, therefore the polygon is convex. Another example would be like the pentagon from yesterday, our example of a pentagon. If I extend these sides, none of them go, right? None of them go inside the polygon. Okay, that would be a convex polygon. Beckman. What are you talking about?
Like the pencil-looking thing, the smart guy, and the cat.
Are you kidding me?
Yeah.
Hold on, I have to turn off my recording for this. This might not. These wise old owls are like definitions. They are terms. They're vocabulary. If you see a key point, that'd be like a key point. That's important for the lesson. A Mr. Happy Pencil is where your homework is, where you get to practice things. And my avatar, the way I see myself, pops up every now and again for just like a nifty tidbit.
Okay, I got it. Hey, wait.
Okay. Shh. 3, 2, 1. You were quiet, Catherine. So, given a polygon, let's go with a hexagon. It is. Okay. Catherine, you got a hexagon here, right? No. You.
Andrew actually clunked up.
You said the word. Your brain
Andrew, I will admit that you outwitted me. I am not going to wave goodbye to you in Carline for a week. I'm not going to wave goodbye to you in Carline for a week. Just because I'm upset. Okay. Yeah, 3, 2, 1. Okay. Because this is something you actually have to know for the test. Catherine, we got a polygon here, right? Okay. If we extend these sides, so this side only goes a certain distance. If I were to extend it, right? No idea. Sorry, I've not seen it. She sits in the front corner, but it looks like that's just nose up there. Hey, folks, shh, quiet. If I extend these sides, notice how I'm not going through the polygon anywhere, right? They're all staying outside the polygon. Alex, quiet. Hey, folks, we only have 6 minutes left. We really got to get back on task, okay? An example of a concave polygon, which is just kind of exactly the opposite. Catherine, here's an example of a concave polygon to where if I were to extend these sides, notice how I'm going through the figure, okay? So a concave polygon is a polygon with sides that, when extended, does go inside the polygon. It doesn't have to be all the sides, it only has to be one of them. If any of those sides pass through the polygon, like we see here, I don't need to test anymore, because I found one that does. That's going to be a concave polygon. Personally, if you can imagine Mr. Schultz sitting in your desk when I was 14 years old, gazing up at the chalkboard, I suppose. How I remember this, concave, you go inside a cave. And so concave polygon, the sides go inside the polygon. It's the best I got. If you have a better one, then feel free to use it. But there we go. Okay. Regular, polygon with congruent sides and angles. Questions on these definitions? That was brilliant. That was actually brilliant. Draw and label each of the following. I've said before how strict I am with the labeling. This is what I expect here. For a regular octagon, we look up at the top. We see regular means it has congruent sides and congruent angles. We know an octagon has to have 8 sides. And so that stop sign that we drew earlier is what we're going to draw here. And especially freehand, it's difficult to really make those sides actually congruent and the angles actually congruent, or in my case, actually connect. But when I say labeling, how are you going to tell me this is a regular octagon? I can see it's an octagon. I can count the sides. I can do that. But how are you going to show me it's actually regular, Bryn?
Oh, like the tick mark.
Okay, I need either tick marks around the entire thing because they're all congruent to each other, or I need an actual side length. Label them each 1. 1, 1, 1, 1, 1, 1, 1, 1, right? All the way around. Or 2, 2, 2, 2, 2, 2, right? You have to show me they are congruent. How about the angles? What would you need to put in for the angles? You had your hand up for the last one, so I was wondering if, no? Arcs is what we would call them. Okay? No, you need both of them. Because the definition of a regular polygon is that sides and angles are congruent. You've got to tell me that both the sides and angles are congruent. Okay? A convex pentagon. Convex, look at the definition. It says that when you extend the sides, they do not pass through the polygon. We actually drew one, our home base or house, whatever you want to call it. Okay? You wouldn't need to label anything here because it has nothing to do with side lengths or angle measures or anything like that. I can see its five sides, and I can see that it is convex. So the labeling here doesn't really apply as much as the last one. Are you done, Alex? Okay. Yes, Max?
one down there where it says like 108 for all of them. Are all the sides equal for that one?
Good question.
Yes, great question. No.
They're not marked. So here's kind of the first geometry hack lesson. If all sides are congruent, all angles are congruent as well. And likewise, if all angles are congruent, all sides are congruent as well. The reason why I want you to do both is because I want to see that you understand that relationship, right? So that is why I'm requiring you to show me both. Also, I'm still kind of mad at you, but if all angles are congruent, all sides will be congruent as well. Okay? Your Anthony, yes. Happy birthday, by the way, since I already, yeah. Go ahead. Go ahead.
So I'm guessing that's the homework. And we don't get
The homework is to finish the page, but you do not, for the second day in a row, get any book assignments.
Also for this one, do you write regular and convex?
Yes. Hold on. Max is asking a valid question here. It says classify each polygon by its number of sides and whether it's concave, convex, or regular. If it's regular, you also have to write that it's convex. Okay. You do need them both. Okay. You do need them both. And then by its number of sides also. So you would say regular, convex, pentagon to be complete for that. Kylie. Correct. If it's not a polygon, then you would say not a polygon. Okay? Alex. Huh? No what? No, not a polygon. Well, you can write no, but then add a polygon. All right, questions, comments, concerns, complaints, comments, congratulations, criticisms. That's all I math.